I'm Adolph Oliver, and this is the lesson on the distributive law. The distributive law now is going to be a workhorse that we're going to get a lot of use of throughout the whole algebra course. Uh, Different than the commutative and associative laws, which we recently talked about. Those stay in the background. First off, let's point out to you that if you have all the numbers, you can use the order of operations. So if you have something like this, a 3 in front of a parens, and inside a 5 plus 2, and you don't have any variables, then, of course, applying the order of operations says do what's in the parens first, and so you would simply then say, okay, the one operation I've got here I've got to do first. 5 plus 2 is 7. Okay, I keep the parens around the 7, bring down anybody else I haven't used, namely the 3 here, and then I can go 3 times 7 and come up with the final answer, 21. So the first point to be made here is that if you have all the numbers, you don't need the distributive law. What's the distributive law set up for? Well, let's modify this problem we just had. Let's say that what you have is the 3 out in front, but now what you've got is 5x plus 2 inside. Well, once again, the order of operations would tell you to do what's in the parens first, but you got a problem. Not only are you adding the 5x and the 2 together, but of course, by the order of operations inside, you would have to take 5 times x first, do the multiplication first before you did the add. Well, there's a problem here. Nobody's told you what value to use for x, so it's not possible to take 5 times something you don't know, let alone add 2 to it. So in a case like this, the order of operations is actually defeated. It tells you what to do, but since you don't know the value of the x, you can't do that. So what we've worked up in algebra is a way to be able to make some progress. We're still not going to get down to a final numeric answer because we don't know what the x is, but notice this. You see this 3 in front of the parens. We, of course, know that any number next to parens means multiply. Well, there are inside the parens here, and we can play this game. If I cover up the parens and just ask you how many terms are inside here, meaning that we've removed the parens from the problem, then the plus is a separator there, and you would say, well, inside the parens are 2 terms. So we can play games like that, even though this whole thing, the way it's written, is officially 1 term. We can look at it and say, well, inside the parens there are 2 terms, and when you say inside, that means you're only looking at the things inside. Well, this 3, of course, is multiplying the whole parens, so that means it's got to multiply everybody inside. So we've got to multiply both of these guys inside, and where the name comes from is you effectively distribute this 3 over all the terms which are inside the parens. Well, let's do that. Okay, I've got 3 times 5x, which gives me 15x, and then I've got the plus sign, and then I have 3 times 2, which is 6. So I can turn around and multiply by this 3, use the distributive law, and come up with 15x plus 6. Now, I haven't got this down to a single number, and I can't unless someone tells me what value to use for x, but we have been able to do some of the work here. We've been able to do the multiplication of the 3 into these guys. This is known as the distributive law, and what it does is it allows you to make some progress in solving the problem. Now, a little bit later on, we're going to bump into cases where what we're going to do is reverse the distributive law. And when you do the reverse distributive law, it's what is known as factoring. There will be a lot of this later in the course. Let me give you a little peek to begin with here at what is going on. Let's get back to where we can see this problem we just did. Now, going the way we've done here is using the distributive law. You turn around and multiply whatever's in front into the guys in the parens. But if we started out with the 15x plus 6, we could turn around now and reverse the distributive law. Okay, reverse it. And here's what we would do. We would ask ourselves, what's the biggest number we can divide into both of these guys at the same time? Well, a 3 will go in the 15 and a 3 will go in the 6. That's the number that goes out in front. Later on, we'll call this the GCF, or greatest common factor. Many of you have probably heard of that already. What you put in the parens then are the leftovers once you turn around and remove this 3 from both of these. Now, how do we remove it? Well, it shouldn't surprise you. When you do the regular distributive law, you're multiplying in. The reverse distributive law should be the reverse of multiplication. What's the reverse of multiplication? Well, it's division. And so this guy that you found as the GCF, the largest thing that'll divide into both of these, in effect what you do is you turn around and divide both of these terms by it. Well, 15x divided by 3 is none other than 5x. And we have the plus sign, and 6 divided by 3 is none other than 2. And so you can see what we did is we got back to what we started with up here. Well, this is what's coming up later on, and this points out why the distributive law is so important. We'll be spending as much time reversing the distributive law as we are going forward with it the regular way. But now, let's take a look at some examples of just doing the distributive law the regular way. Here comes our first one, and we have a number of these to take a look at. Okay, here we are. Now notice, again, we don't know what x is, so there's no way we can take and add 1 to x. The order of operations would, of course, tell us to do what's in parens first. So, not being able to do that, we can make some headway here by taking the guy in front and distributing them over each of the terms inside. And so what do we end up with? Well, with 10 times x, which is 10x. Then we have the plus sign. 10 times 1 is just 10. So we could turn around and at least make some progress on it here by using the distributive law. Now, you can have both plus and minus signs, and we'll talk officially about signs a bit later on in the course here. But the same idea. Here's one of the terms inside the parens. It has a letter, and we don't know its value, so there's no way we can work on this guy inside and figure out what his numeric value is. But the 2 in front here is multiplying the parens because it's next to it. So once again, let's just distribute that 2 in. 2 times negative 3 is negative 6. We just keep the minus sign. 2 times 3 is 6. Then we have a plus sign. 2 times 2 is 4, but don't forget that you've got the r there. So once again, we're able to make some progress here. Now, what's multiplying out in front can also have some variables with it. So here's an example where what we have out in front to distribute is 8a. Again, we can't use the order of operations because we don't know what a is, so the only way we can make progress is distribute this guy in front inside. Now when you do this, multiply the numbers together and then multiply the letters. 8 times 5 is 40. A times a is a squared. Then we have a plus sign, and the next guy, 8 times 2 is 16. But don't forget there was also a single a here. So there we go. 40a squared plus 16a is as far as we can go, but we have again made some progress. Okay, another example here. This one just has a couple of minus signs in it. Once again, we're distributing the guy in front into everybody. So we've got a single minus sign here. 7 times 9 is 63, and don't forget we've got the b. Then there's a minus sign, and 7 times 7 is 49. Once you get the hang of the distributive law, it's a really simple thing to do. But what you'll find are cases where sometimes folks try and throw you a little bit of a curve. And notice here, here's our guys in parens again. But now we're used to having the number in front that we're distributing with. Here it's shown in back. Now I put a multiplication dot here. That's not really needed. This 8 could be right against the parens here, and that will still mean multiplication. Any number against parens means multiply. Now you could turn around and rewrite this, put the 8 in front of the parens, and then distribute, but that's some extra effort. It works exactly the same if you distribute it from the back. So let's just do that. I'll take the 8 times the first guy here. 8 times 6 is 48, and we've got a single r. And then the plus sign, and then 8 times 8 is 64. So the distributive law works perfectly well whether you're doing it from the front or the back. And of course, you could have a variable in the back with it. So here's our example here again, one of these backwards guys. So we'll simply just distribute it from the back. 3x times x, well, there's a 3, but we have x times x, so there's x squared. Then a plus sign, 3 times 10 is 30, but of course remember there was a single x. So 3x squared plus 30x. Okay, a couple more examples to look at here. Let's see, we've got 2b in front of the parens where we have b minus 9 inside, so at least we've got what we're multiplying back out in front again, although we saw it works perfectly well from the back end. The 2b is what we're distributing in, so again, hit everybody inside. Here we go. 2b times b, well, it's a 2, and b times b gives me b squared. Then we have a minus. 2 times 9 is 18, but don't forget there was a single b here. So 2b squared minus 18b. Okay, well, our last example on this distributive law stuff, and I think you've seen it. Once you see the hang of it, it's an easy thing to do. We've got this 4r that is next to the parents, so we'll just distribute it into both of these guys. The first term has a minus sign, so we indicate that. 4 times 8 is 32, and don't forget the single r that was here. Now, the second guy inside has a minus also, so there it is. 4 times 5 is 20, but this time we have an r in front and an r in here, so r times r gives me r squared. Okay, well, as I said, the distributive law is something that we're going to be using a lot, not only forward, but also reversing later on.